Okay, this is Mark Summers again from Summers Technical Services. As you can see, we've got our model assembly, my assembly model finished up. And take note of the file naming conventions. We used the ZZ suffix on the file name since we're doing assembly models. We've got multiple parts assigned to the same project, so we had to add another designator. So we use odd numbers for parts, 01, 03, 05, 07. And for assemblies, we use multiples of 10 as the ZZ designator. So the top level assembly is always a -10. First subassembly is -30, -50, -70 on down the line. And if we have any mirror image parts, they'd be -02, 04, 06. And if we have any mirror image assemblies, they'd be -20, -40, -60. So for these, we don't have any mirror image parts, so it's going to be sticking with the odd number, part number, dash numbers, and the odd numbered or every other multiple of 10, 10, 30, 50 assembly models. All right, so last thing on this too, this pipe I built since we checked out last time. So I'll give you some specifications on a Schedule 40 pipe to put in here. You can build that model, and we'll call it -7. When you constrain these guys, the last degree of freedom is a rotational degree of freedom, and I left that loose. You can see these minus signs, and on the not only fasteners but also the pipe. The pipe is kind of free to rotate, and you won't know where that pipe is going to rotate to, or those fasteners where they're going to stop, and you're going to snug them up against that pipe until you put the real assembly together. So I don't get too worried about not constraining these fully. But if you're getting nervous about that minus sign and afraid you're going to lose 5 points, the way to fix it is to go find your constraint, your concentric constraint, right click on it, and then choose this lock rotation option. The lock rotation just takes away that last degree of freedom without having to put a specific constraint to do that. So right click, lock rotation on the concentric constraint for these fasteners will take care of that last degree of freedom. And you can right click and edit feature and get to that same checkbox, lock rotation. But it's easier, I think, just to right click without going all the way into the constraint to do that. And we want to do it on the pipe, we can do that too. There's the pipe. Every part has its own folder with mates related just to that part. There's another folder here at the bottom called mates, and this is where all the mates for the whole model are. This is a nightmare to try to go through because there's too many of them. So always go to the part and then open up the part mates, and it just gives you a subset of all the mates. So this guy here needs to be lock rotation somewhere. Coincident. Oh, it doesn't have a coincident constraint, so I can't lock rotation on this one. So that's okay. We'll just leave it loose because all it's doing is spinning. All right. So the point of the video here is to do the assembly drawing. So let's do that. So I'll say File, New, and I want to pick the size of the drawing that will allow us to do a full-size scale view at 1:1. And it turns out that I believe B is the one that does that the best, and we'll find out if I made a mistake or not. So here's my B size template. Since I have the assembly model open, it pops up in this box here. So if I double click and if I widen this up a little bit, I'm going to grab the ISO view, and sure enough, there it is. And so right now it assumed I wanted 1:2, which is not what I want. I'm not going to change the view scale in the drawing view itself. I'm going to go to the sheet and change the sheet scale. The sheet scale is assigned, each sheet has a default sheet scale, and that's what shows up in my title block. That's why this template is so nice. I don't have to change that text down there because that follows the sheet scale, and I want all the views to follow the sheet scale. And right now that view, if I look at the properties down here, it is following the sheet scale. The sheet scale just happens to be not what I want. So I'm not going to go custom scale and change this 1:1. I'm going to leave it at the sheet scale, but I'm going to right click on the sheet and say properties, and change the sheet scale to 1:1. Apply changes, okay. Now it's 1:1. And that looks pretty darn good. I like that. And so I want to put the view kind of right here in the middle. And so that's step one. And so if we did this in AutoCAD, it would take you half a day to make those views and do your lines, and it takes forever. And so here I just push one button. So that's why I prefer parametric CAD modeling and CAD drawing creation as opposed to 2D drawings in AutoCAD. All right, so that was step one. Step two is to make the bill of materials. This is going to be painful. It's going to take about 13.5 seconds. You go to the tables pull down and you say bill of materials, and it says select the drawing view to specify the model for creating a bill of materials. Well, this is my only view. That's got all the parts in it, so I'm going to select that view. And over here it's got all kinds of different options. And for now, for reasons of expediency, I'm not going to go through all these details, but just understand there's lots of options over here to customize it however you want. But we'll just leave the default. I say OK, and then I place the bill of materials. Boom. And that's it. It's totally freaking parametric. It's got item numbers. It placed item numbers in the order in which I placed the parts in the assembly model. The part number comes from the file name of each part. Whoever made this template was a genius. I don't want it to type those in. I want it to be parametric. What about the description? Every one of these part models has, under File Properties, has a description. And so you're going to have to go make sure, hopefully you've already done it, like I did. If not, then you have to go back and add these descriptions. You can't double click on this thing and type them in, because that means the information would live in two places. And that's lousy. I want the information to live in one place. So the part number lives in one place. That's the file name of the part. The description lives in one place. That is the properties in the part that you type that in. The quantity is parametric because it knows how many parts I've got. If I add another fastener, that number is going to bump up to 3. So this is all parametric. All right, so that's done. The only thing that's lousy about my template is the fact that this font, for some reason this font doesn't come in. It doesn't look like the same font. So we have to fix that manually. Sorry about that. It's going to add another 9.5 seconds to our task list here. You click the button up there to grab the entire table. You're going to see this button is pushed in right here. It says Use Document Font. I'm going to turn that off by pushing the button. And that allows me to choose the correct font. And you're going to want to write this down. It's Solidworks Roman D is the name of the font. When I select that, it looks beautiful now. The only thing that doesn't look beautiful is the fact that this thing wraps around, but that's easy to fix. I drag this column over a little bit, and now it looks beautiful. And now I'll dock it. See how it docks nicely? It snaps there, snaps there. That couldn't be better. All right, so that's that. Let's move this over a little bit. Now it's time for the balloons. Well, this is going to take almost 60 seconds. So hold on to your hats. We're going to go to the balloon button, and we're going to click on the first part, which is this V block, and we're going to place the balloon. That's item 1. Now we're going to select the U clamp, and before we place it, I want to come over here to the property dialog box here, and I want to turn on quantity so it adds the number, adds that quantity to the call out. And I can do a split balloon, but the default is to put a quantity with, like in this case, 2x. If I want to switch the side that the 2x shows up on, I can hit these buttons down here, but I want it like that, and so I want to click right there. And now I want to add one for the fastener, and I'll click right here and make that. That's on the wrong side, so I'm going to come down here and flip it to the other side. And now we've got the pipe, the last one. The pipe doesn't need quantity, so I'm going to turn that off. Wherever it went. Where did it go? Quantity, turn it off. If there's only one of them, you turn off the quantity option. And there's item 4. Right click, done. So as advertised, that was 49 seconds to do that. So now you've got to go File Properties, and you've got to go in and change these parameters in the title block. Don't double click on the title block and try to change the text. Go File Properties and find this text up here and change it. In my case is 061-00-11-10. This is Student 0, Assignment 11, Assembly. The top level assembly is 10. And these other things, we'll talk about that in class, but you need to change these. Use the right format for the names and the dates. Drafter is me. M, do all caps. M. Summers. Use that convention. First initial, period, last name. The date, 2 numbers for a date, 3 letters for a month, 4 numbers for a year. So today is 23 July 2020. Checker, have some fun with a checker. This is who's going to check your drawing. I think Ian Anderson's going to check my drawing today. I think he's coming to town. And the check date is today. And you get the idea. So scroll down here, fill all this stuff out per the discussion during class. And then these up here, these are dumb text. And so these you do manually. So you double click on the revision block and you just go edit this dumb text. So I want to select it, do a space, that's a no change rev, dash rev, that's the initial release. So you click off of it to get out of the editing. I want to double click again. Now I'm inside here. I want to click on the end and make it a release. Arrow over, get rid of not, and type in initial release. To get out of it, I click out of it. And then I do the same thing over here and over here. For the notes up here, we're going to add notes for the material and finish. On this case, we're not going to have any material and finish because the material for each one of those individual parts is going to show up on the part drawing. Right? At this point, the part's already made, the material's already chosen, the finish is already chosen, whether it's anodize or passivate or zinc plate, whatever the finish is, it's already happened. And so unless I want them to paint this thing red after they assemble it, there is no finish on the assembly, there is no material. So these notes, we can go away. When we do part drawings, these notes are going to be filled out, and we'll talk about how to do that some other time. And so down here in the title block where it says material, just put N/A, not applicable. Finish, N/A, or none, either one. All right, we've only got one sheet. Sheet 1 of 2. Sheet 2 we don't need, so I want to right click on sheet 2 and say delete. And now it says sheet 1 of 1. And once you get all your title block done and text done, then you're going to do 2 things. You're going to do a PDF plot of this drawing, and you're going to submit the PDF plot. Do it 11 by 17, full scale, PDF plot. And then for the assembly, you're going to do a pack and go. Pack and go will take the top level item, in this case the assembly drawing, and it will make a copy of it plus all the sub parts and assemblies. So if you do a pack and go on the assembly drawing, you're going to get the assembly model and you're going to get all 3 parts all together. So let's see how to do that, and we'll call it a day. Once you save this, you save File. Make sure to save this first before you do the pack and go. File and then pack and go. And it's going to ask you, it's going to have all these options. It's got tons of options like all these SolidWorks commands. We're going to take the defaults. It knows all the files that it needs to make this, so it's already selected those. All you have to do is go browse to save to the folder you want to browse to, you want to save it to. So in your case, you're going to go to text. You're going to go to your class folder, and you're going to go to A11, and then maybe you make a new folder called Pack and Go, because you don't want it to overwrite your part. This is a copy of everything. So I've selected the new Pack and Go folder. I'm going to say select folder, and then I want to watch the magic happen. I'm going to come over here and I'm going to go find that folder and show you that it's actually empty at the moment. So right now that folder is empty. But when I say I've selected the folder right there. I browse to find this folder that I just made. And when I hit save, watch what happens. It gives me an error message. Oh, because I haven't saved it yet. So save your drawing before you do the pack and go. And you can see they all showed up except the assembly drawing because I haven't saved it yet. So make sure you save it to your local hard drive like you've been doing. Then do pack and go, and you should get 1, 2, 3, 4 part models, 1 assembly model, and then also the drawing if I would have saved it. All right, well, that takes us to the finish line on our latest assignment, double V block assembly. So we're going to move on to bigger and better assembly models, start talking about working drawings, what that means, and start leading into our final project that we'll be doing the last week of the semester. So until next time, enjoy yourself, and we'll see you next time.